In this video, let us see the topic testing of hypothesis. Statistical hypothesis. In making statistical decisions, we make assumptions which may be true or false is called the statistical hypothesis. Null hypothesis. Null hypothesis is denoted by the symbol H naught. For applying the test of significance, we first set up this null hypothesis, which is a statement about the population parameter. This statement is usually a hypothesis of no difference between sample statics and population parameter under consideration. So it is called null hypothesis and is denoted by H naught. Next one is alternative hypothesis H1. Suppose the null hypothesis is false, then something else must be true. That statement is assumed to be the alternative hypothesis and is denoted by H1. Error in sampling. After applying a test of significance, a decision is to be taken to accept or reject null hypothesis. So we have two types of errors, that is type 1 error is a rejection of null hypothesis H naught when it is true, and the type 2 error is the acceptance of null hypothesis H naught when it is false. So for this corresponding error, we have the level of significance which is denoted by the symbol alpha, and normally if this level of significance is stated in the question, then we can consider that, or else generally we used to consider alpha equal to 5%. One-tailed and two-tailed test. If theta naught is a population parameter and theta is a corresponding sample statics, and if we set up the null hypothesis H naught as theta equal to theta naught, then the alternative hypothesis, which is complementary to H naught, can be chosen in the following way. First one, H1 is theta not equal to theta naught. Second one is theta is less than theta naught, and the third one is theta is greater than theta naught. So alternative hypothesis, wherever H1 is given in 1 is called the two-tailed test, and given in second condition is the left-tailed test, and H1 condition given and the third is the right-tailed test. So here level of significance alpha will be considered for solving the problem. Now let us see what is critical region. For a test statics, the area under the probability curve, which is normal, is divided into two regions, namely the region of acceptance H naught and the region of rejection H naught. The region in which H naught is rejected is called the critical region. The region which is accepted is called the acceptance region. Next, let us see the procedure for testing of hypothesis. First step is to set up the null hypothesis H naught. Next one, to set up the alternative hypothesis H1 and check whether it's one-tailed test or two-tailed test. Third one is to choose the level of significance alpha, generally 5%. And fourth one is the test static t minus e of t by standard error of t. Next one is to compare the calculated value as well as the table value, and we have to decide whether to accept H naught or reject H naught. That is, if mod z is less than 1.96, H naught may be accepted at 5% level, and if mod x is greater than 1.96, H naught may be rejected at 5% level of significance. And if mod z is less than 2.58, H naught may be accepted at 5% level of significance, and if mod z is greater than 2.58, H naught may be rejected at 5% level of significance. For a single tail test, we compare the computed value of mod z with 1.645 at 5% level of significance and 2.33 at 1% level of significance, and accept or reject H naught accordingly. Now, test of significance of small samples. When the sample size is less than 30, then it is called a small sample, and the distribution will be small sampling distribution. So here we have some important tests for small samples. Those are standard t-test, f-test and chi-square test. Now let us see t-test. That is, the test static for this distribution is t equal to x bar minus mu by s by root n, where x bar represents the sample mean Mu represents the population mean, S denotes the standard deviation of sample, and N is the sample size. And also degrees of freedom is given as N minus 1. Now let us see a problem based on this. The mean lifetime of a sample of 25 bulbs is found as 1550. That means sample of 25 bulbs, it means N value is 25. And mean lifetime of sample, so X bar value is 1550. Then standard deviation value is given as 120. Now the company manufacturing the bulb claims that the average life of their bulbs is 1600. So we have to check this as at 5% level of significance. So sample size is N, sample mean is 1550, standard deviation is 120, population mean value is 1600. First, let us set up the null hypothesis H naught, that is mu equal to 1600. Step 2 is set up the alternative hypothesis H1 where mu value is not equal to 1600. So since it is not equal to, we use a two-tailed test here. Next step is alpha equal to 5% which is 0.05. Now the degrees of freedom is n minus 1 equal to 6, and so we have T alpha equal to 2.064. This is from the table value. Now next step, fourth step is to apply the test static T equal to x bar minus mu by S by root n. Here we know the x bar value was 1550, mu value was 1600, standard deviation value was 120 and the sample size value was 25. So we have the calculated value was minus 2.08. So mod value of T is 2.08. Now let us compare the table value with the calculated value. Here the calculated value is is greater than the table value. Since calculated value becomes greater, we need to reject the H naught. That means alternative hypothesis H1 is accepted. So the conclusion is the claim is not acceptable. Thank you.